April 1944, a narrow supply route, carved through rolling fields scarred by artillery craters. Dust rose behind a convoy of Allied trucks, engines straining against mud and ruts. Soldiers hunched behind their wheels, rifles at the ready, eyes scanning the tree line for any sign of ambush. A sudden burst of gunfire ripped through the air, striking the lead truck. Sparks flew, metal groaned, yet the vehicle kept moving. The next volley hit another truck, and again it held. Mechanics and drivers exchanged bewildered glances. These trucks had survived hits that should have disabled them. Crude patches of metal, welded plates in odd shapes, had transformed fragile vehicles into rolling shields. Somewhere nearby, the secret of this resilience was born from a farmer's hands, a broken plow blade, and a spark of ingenuity. What began as simple improvisation in a quiet rural field had now reached the battlefield, quietly saving lives, preserving vital supplies, and defying enemy fire. As the convoy pressed on, soldiers could only wonder who had devised such a simple yet effective solution. Each rattling mile, each near miss, underscored the unexpected power of ordinary ingenuity turned extraordinary. In the chaos of war, one man's innovation had become the unseen armor of the Allied supply lines. By 1944, the Allied forces were executing operations across multiple fronts, relying heavily on supply convoys to maintain momentum. Trucks carried ammunition, food, medical supplies, and fuel to frontline units. These convoys traversed narrow roads, often unpaved and scarred by artillery fire, mines, and shell craters. The vulnerability of supply vehicles was a constant concern. Even a single ambushed truck could disrupt operations for hours, leaving soldiers exposed and slowing critical advances. Maintaining the flow of materials was as crucial to the war effort as winning battles themselves. The enemy recognized the strategic importance of these convoys. German forces deployed reconnaissance teams, snipers, and light artillery to interdict supply lines. Ambushes were common, often targeting the lead and rear trucks, intending to immobilize the convoy. Mines buried along roads were another threat. Engineers could repair roads quickly, but lost vehicles meant lost supplies and delayed reinforcements. Each truck was more than a vehicle. It was a lifeline. Protecting them became a tactical priority, yet available armor was limited and difficult to produce at the scale required. Mechanics and soldiers experimented with available materials. Metal sheets, salvaged from damaged vehicles, were sometimes bolted or welded to trucks, offering rudimentary protection. However, these solutions were heavy, slow to install, and inconsistent in effectiveness. A systematic method to enhance truck survivability had yet to emerge. Every mile driven without innovation risked casualties, lost supplies, and compromised operational efficiency. Amid this pressure, local civilians occasionally provided unconventional solutions. Farmers, blacksmiths, and tradesmen familiar with metalwork and machinery began assisting engineers, applying practical knowledge honed in non-military contexts. Their contributions were often overlooked, but in critical moments, these improvised solutions could be decisive. One such civilian, a farmer with years of experience working steel and maintaining plows, would soon change the equation entirely. This farmer's workshop was modest but well-equipped. Spare metal, hammers, welding tools, and scrap machinery filled the space. Accustomed to repairing broken implements under tight deadlines and harsh conditions, he developed an intuition for metal durability, leverage, and structural reinforcement. It was a skill set forged by necessity, patience, and observation. When Allied mechanics presented the problem of vulnerable trucks, the farmer saw an opportunity. The same principles that kept plows functional in fields could potentially protect vehicles from bullets and shrapnel. The challenge was significant. Trucks traveled at speed, often over uneven terrain, and had thin sheet metal bodies vulnerable to small arms and light artillery. Any improvised armor had to be lightweight, easily attached, and effective enough to prevent critical damage. The farmer began examining farm tools, implements, and scrap metal, considering which materials could provide the greatest protection. His attention fell on a broken plow blade, hardened steel, angled, and already designed to withstand immense force in soil. It was an unassuming object with enormous potential. Military engineers initially dismissed the idea. A plow blade seemed primitive compared to purpose-built armor, and improvisation in active combat zones was risky. Yet the ongoing losses of trucks and supply delays made inaction costlier than experimentation. With careful measurement, adjustment, and testing, the farmer proposed a system of mounting the plow blades onto truck sides and undercarriages. The angle and hardness of the steel could deflect bullets and shrapnel, and multiple vehicles could be reinforced quickly with minimal disruption to operations. Thus, what began as a civilian observation in a quiet workshop would become a wartime innovation with profound implications. The stage was set for an extraordinary fusion of ordinary skill and military necessity. One broken plow blade, transformed into improvised armor, was poised to change the survivability of Allied supply trucks, preserving both cargo and lives as convoys pressed toward the front lines. The operational environment for Allied supply trucks remained perilous. Convoys moved through forests, river crossings, and open fields where ambushes could strike from any direction. Soldiers relied on reconnaissance, road scouts, and limited armor to reduce casualties. But threats were unpredictable. Enemy snipers, light artillery, and improvised explosive devices exploited any vulnerability. Trucks were essential, yet historically underprotected. Every journey risked damage, delay, or destruction, making supply chain resilience a persistent concern for commanders and field personnel alike. Mechanics at the airfields and depots worked tirelessly to repair damaged vehicles. Limited spare parts, heavy workloads, and ongoing engagements meant that even minor damage could sideline a truck for hours or days. Commanders faced tough decisions: risk using partially repaired vehicles or delay missions, affecting entire operational timelines. The need for practical solutions was immediate. In such a high-stakes context, innovation, even unconventional, became a necessity. Civilian expertise became a critical resource. Farmers, familiar with repairing tools and manipulating heavy steel, could offer insights that military engineers sometimes overlooked. This farmer had spent years maintaining plows and wagons, developing a deep understanding of steel's strength, angles, and stress points. He was accustomed to improvising solutions under tight deadlines, a skill that translated seamlessly into solving military vehicle vulnerabilities. What was commonplace knowledge in his field became extraordinary when applied to armored protection. The idea emerged gradually. Observing the damage to trucks, the farmer recognized parallels between bullets striking thin metal and soil impacting a plow blade. The steel in the broken plow blade was hardened, angled, and designed to withstand immense force. Exactly what a truck needed in combat conditions. By attaching these blades to vulnerable areas of trucks, the steel could deflect bullets, shrapnel, and even absorb minor impacts that would have otherwise disabled vehicles. Early prototypes involved simple mounting techniques. Blades were cut, shaped, and welded or bolted to trucks' sides and undersides. Soldiers were initially skeptical. The modification appeared crude, and the threat of malfunction or interference with vehicle operation loomed. But field testing proved the concept. Trucks fitted with plow blades withstood small arms fire, debris impacts, and rough terrain far better than unprotected counterparts. Each success reinforced confidence and validated the farmer's approach. Commanders observed quietly, realizing the potential strategic advantage. Armored trucks could maintain supply lines with fewer losses, keeping critical resources flowing to the front. The improvisation also introduced a psychological element. Drivers felt safer, mechanics worked with less anxiety, and soldiers' morale increased knowing that cargo and vehicles had an additional layer of protection. Even minimal increases in survivability could significantly influence operational outcomes. By the time the first full-scale implementation was ready, word of the innovation had spread through the supply units. Soldiers and mechanics became advocates, recognizing that a civilian's ingenuity could directly influence battlefield resilience. The plow blade, a simple agricultural tool, had transformed into a practical instrument of protection, bridging the gap between civilian skill and military necessity. The farmer's innovation exemplified a wartime truth. Extraordinary solutions often emerge from unexpected sources. Conventional engineering alone could not meet every challenge. Human creativity and practical experience proved indispensable. What began as a broken blade in a quiet workshop was now poised to redefine truck survivability, influence tactical planning, and alter the course of operations along critical supply routes. The human element in the improvised armor solution was as crucial as the metal itself. Soldiers and drivers were accustomed to fragility in their vehicles. Every convoy carried the constant awareness that enemy fire could disable their trucks and leave them stranded. The introduction of the plow blade armor transformed this mindset. Drivers approached missions with a renewed sense of confidence, understanding that the once vulnerable trucks now had an extra layer of protection. Mechanics also experienced a shift in perspective. Initially skeptical of civilian improvisation, they quickly realized that the farmers' knowledge of metal and angles complemented their technical expertise. They worked side by side, installing blades, testing mounts, and adjusting fittings to ensure optimal coverage. The collaboration fostered mutual respect. Military personnel recognized the value of practical civilian experience, while the farmers' insights were validated under real-world conditions. Psychological endurance played a critical role. Maintaining focus during long convoys required constant vigilance, and the presence of improvised armor alleviated some stress. Drivers reported feeling less anxious under enemy fire. Mechanics found confidence in the reinforced vehicles they maintained, and officers noted a subtle but measurable boost in morale across the supply units. This human factor, the intersection of trust, confidence, and shared purpose, was central to the hack's effectiveness. From a technical standpoint, adapting a plow blade to serve as armor required ingenuity and precise execution. Plow blades were designed for soil, not bullets or shrapnel, yet their hardness and shape made them surprisingly effective in deflecting small arms fire. The challenge lay in attachment and orientation. Engineers needed to ensure that the blade's angle would maximize deflection while avoiding interference with vehicle movement or suspension. Mechanics employed welding, bolting, and reinforcement techniques to secure each blade. Cut and shaped precisely, the steel panels covered critical sections of trucks, engine compartments, cargo areas, and undersides, providing protection where vulnerabilities were greatest. Even minor misalignments could compromise effectiveness, so precision was paramount. The integration of civilian skill and mechanical knowledge allowed a reliable, repeatable process that could be scaled across multiple vehicles. Tactically, the improvised armor had significant implications. Supply trucks had always been soft targets, slowing or halting operations when damaged. With reinforced vehicles, convoys could maintain speed and operational tempo, reducing vulnerability to ambushes and roadside attacks. Commanders could now plan routes with increased confidence, knowing that each truck had a higher likelihood of reaching its destination intact. The armor also altered enemy engagement. Small arms fire and debris that previously disabled trucks now had reduced impact, forcing opposition forces to expend more resources or risk exposure to return fire. Even minimal enhancements in survivability could influence the success of multiple missions, demonstrating how a simple civilian innovation could create strategic advantages on the battlefield. Commanders faced a delicate balance between operational necessity and adherence to standard protocol. Approving the use of civilian improvisation on military vehicles carried inherent risk. A misjudged design could endanger soldiers, damage equipment, or violate regulations. Yet the ongoing threat to supply convoys left few alternatives. Leadership decisions in this context were as much about trust and judgment as they were about technical evaluation. Field officers observed the farmers' work closely, monitoring early tests and evaluating outcomes. Gradually, skepticism gave way to cautious support. By sanctioning the armor adaptation, leaders demonstrated flexibility under pressure, a hallmark of effective wartime command. They understood that strict adherence to conventional engineering could not resolve every logistical vulnerability. Empowering individuals to apply unconventional solutions preserved both the operational tempo and the lives dependent on it. German forces, focused on disrupting supply lines, were unaware of the improvised armor protecting Allied trucks. Reconnaissance and ambush strategies relied on predictable vulnerabilities, yet the introduction of plow blade armor altered these dynamics. Trucks that previously could be neutralized with small arms or light artillery now withstood damage that would have halted convoys. This unseen advantage forced tactical recalibration. Enemy units expended ammunition on vehicles that absorbed impacts, delaying attacks and reducing efficiency. While not a decisive battlefield weapon, the armor indirectly influenced enemy strategy. By denying predictable vulnerabilities, the improvised solution provided a subtle but meaningful operational edge, demonstrating that civilian ingenuity could shift tactical outcomes without direct combat engagement. The psychological dimension was profound. Soldiers and mechanics witnessed a civilian innovation tangibly improving their survivability. Confidence grew, trust in improvisation developed, and collective morale surged. The knowledge that trucks could endure more enemy fire reduced fear, encouraged initiative, and strengthened cohesion within supply units. Mechanics derived pride from applying their skills alongside civilian expertise. Drivers felt empowered, recognizing that proactive measures could mitigate danger. The morale boost was not merely emotional. It translated into more disciplined, attentive, and confident operations. Human psychology in wartime is often fragile, yet the plow blade armor exemplified how innovation could bolster resilience and reduce stress under persistent threat. The armor adaptation also reshaped supply logistics. Trucks that previously required constant repair could now complete longer missions without interruption, improving efficiency and reducing downtime. Materials previously allocated for repeated vehicle replacement were conserved, allowing resources to be redirected to other critical operational needs. The ease of implementation was key. Using available plow blades, mechanics could reinforce multiple trucks quickly, without waiting for specialized armor production. This flexibility enhanced the airfield's and supply units' operational resilience. In effect, a single broken plow blade translated into both a tactical advantage and a logistical force multiplier, preserving resources while sustaining mission readiness. The first convoy of trucks fitted with plow blade armor rolled out under gray skies. Soldiers, mechanics, and officers gathered, tension vibrating through the air. Every vehicle carried vital supplies: ammunition, rations, fuel, the lifeblood of advancing Allied units. Each driver understood the risks: enemy ambushes, sniper fire, and hidden explosives. Yet this time, confidence replaced anxiety. The improvised armor promised protection, a silent shield born from a farmer's ingenuity. The convoy moved cautiously along a winding dirt road flanked by dense forest. Scouts advanced ahead, alert for signs of enemy activity. Every creak, every vibration under the reinforced trucks was a reminder that these vehicles were now unlike any the drivers had handled before. The plow blades, welded and bolted with precision, deflected stones, debris, and minor impacts. Small arms fire that would have previously penetrated thin metal bounced off at angles calculated by the farmer's experience. As the lead truck rounded a bend, a sudden crack of rifle fire rang out. Bullets struck the vehicle's side. Sparks flew. Soldiers braced for the impact to halt the engine or breach the cabin, yet the truck continued forward unscathed. Shocked glances exchanged among drivers and ground crew confirmed the effectiveness of the modification. One after another, trucks were tested by enemy fire, each emerging intact. The improvised armor had transformed vulnerability into resilience. Mechanics on the convoy maintained constant vigilance, ready to address any unforeseen issues. Hoses, mounts, and bolts were inspected on the move. But the modifications held. Drivers reported smoother handling and minimal interference from the added metal, validating the farmer's precise calculations of weight distribution and structural integrity. The once crude idea had become a reliable field solution. Midway through the route, the convoy encountered a more coordinated attack. German infantry attempted to disable the lead and rear vehicles, aiming to trap the supply line. Rifle and machine gun fire riddled the trucks, but the armor absorbed most impacts. Shrapnel glanced off angled steel, and critical components remained unharmed. Soldiers were astonished. What had seemed like an untested civilian experiment was now actively preserving lives and cargo under live fire. The psychological impact was immediate. Drivers pressed forward with renewed determination, mechanics operated with calm precision, and officers observed the strategic advantage in real time. Each truck that survived the ambush strengthened morale and reinforced trust in both the modification and the human ingenuity behind it. Soldiers began sharing stories of near misses that were mitigated solely by the improvised armor. By the time the convoy reached its destination, the effectiveness of the plow blade armor was undeniable. Cargo was delivered intact, no vehicles were lost, and soldiers returned with first-hand accounts of the innovation's reliability. The success was more than mechanical. It validated a civilian's contribution to the war effort, demonstrating that practical, experience-driven solutions could meet and exceed the demands of battlefield conditions. The initial engagement marked a turning point. The combination of technical precision, human skill, and tactical necessity proved decisive. A broken plow blade, once a discarded implement, had become an improvised shield, ensuring operational continuity, saving lives, and preserving essential supplies. The stage was now set for broader deployment and further testing under more intense enemy encounters, where the full impact of this innovation would be realized across multiple supply routes. Following the success of the initial convoy, the plow blade armor was rapidly implemented across multiple supply routes. Trucks that had once been fragile and vulnerable now moved with confidence, their reinforced sides and undersides absorbing impacts that would have previously stopped them cold. Officers monitored operations closely, logging damage and performance, while mechanics refined mounting techniques, ensuring that each vehicle received optimal protection without compromising speed or maneuverability. Enemy forces, still unaware of the improvisation, continued targeting convoys. Reconnaissance teams reported firing positions along narrow roads, anticipating easy strikes. Yet each attempt proved increasingly ineffective. Bullets struck reinforced areas, ricocheting harmlessly, and light artillery shells caused only superficial damage. Supply trucks reached their destinations fully intact, delivering essential resources to frontline units on schedule. The operational advantage was profound. One farmer's ingenuity had transformed the survivability of a key logistical network. Soldiers began to notice patterns. Where previously a single ambush could halt an entire convoy, the armor allowed trucks to absorb fire and maintain momentum. Drivers became bolder, navigating exposed stretches with confidence. Mechanics worked in tandem with drivers, adjusting mounts and checking welds, forming a seamless operational chain that combined human skill with improvisation. Officers began to plan missions with new optimism, understanding that vehicle losses would no longer cripple their supply lines. The psychological impact extended beyond the convoy. Morale across the airfield and supply depots surged. Crews shared stories of near misses and vehicle resilience, fostering a culture of innovation and trust. Soldiers recognized that ingenuity, even from unexpected sources, could influence operational success in tangible ways. The farmer, previously a peripheral figure, now commanded respect for his solution, and his methods were quietly disseminated for replication at other critical locations. In one particularly tense engagement, a convoy moving through a heavily contested valley came under sustained rifle and machine gun fire. Several vehicles were struck repeatedly, yet the plow blade armor absorbed the impacts, protecting engines, fuel tanks, and cargo. Drivers maintained course, mechanics monitored mounts under fire, and the convoy continued without halting. The success was so pronounced that officers documented every detail, from blade angle to bolt placement, ensuring that future implementations could reproduce the effect. The integration of civilian ingenuity, military mechanics, and tactical necessity demonstrated a remarkable principle. Operational success often depends on adaptive problem-solving under pressure. The plow blade, once broken and discarded, became a symbol of resilience. Its practical application saved not only supplies but lives, proving that creativity and technical understanding could rival conventional engineering in effectiveness. By the end of the operation, the cumulative effect was clear. Supply lines that once risked disruption now functioned reliably. Morale was strengthened, and the Army had gained a subtle but meaningful advantage over the enemy. Trucks continued to arrive on schedule, demonstrating that human ingenuity, when combined with disciplined execution and tactical awareness, could decisively influence wartime. Logistics, the climax of this story. The full operational deployment of improvised armor under combat conditions illustrates the extraordinary impact of one individual's resourcefulness. A simple farmer's broken plow blade had evolved from an agricultural tool to a protective shield on the battlefield, preserving both the lives of soldiers and the integrity of crucial supply networks. This turning point underscored that innovation, collaboration, and adaptability were as critical to victory as firepower and strategy. The immediate aftermath of the plow blade armor deployment was a mixture of relief, admiration, and practical evaluation. Supply convoys, previously vulnerable to ambushes and small arms fire, now demonstrated unprecedented resilience. Officers and mechanics documented every aspect of the innovation, from the angle of each blade to the methods of attachment, ensuring that the lessons learned could be replicated across other supply routes. The farmer's contribution, initially considered unconventional, had proven itself under real combat conditions. Soldiers reflected on the psychological impact of the reinforced trucks. Confidence replaced fear as drivers navigated once dangerous routes with assurance. Mechanics, who had initially been wary of improvisation, now understood the precision and ingenuity involved. Each vehicle that survived enemy fire reinforced the credibility of civilian innovation, fostering trust between military personnel and those outside traditional chains of command. Stories of near misses and successful armor interventions spread quickly, boosting morale across the airfield and adjacent supply depots. Operationally, the reinforced trucks allowed for uninterrupted delivery of ammunition, fuel, and food to frontline units. Previously, delays caused by damaged vehicles had jeopardized entire campaigns, forcing commanders to adjust tactical plans. With the new armor, supply lines functioned reliably, allowing units to maintain momentum and execute missions with greater confidence. Every truck that reached its destination represented not just logistical success, but also lives preserved and objectives maintained. Military engineers conducted thorough evaluations of the armor after each convoy returned. They analyzed stress points, metal deformation, and mounting stability, ensuring that modifications could withstand repeated engagements. Minor adjustments improved performance further. Bolts were reinforced, blade angles fine-tuned, and welds inspected for durability. The field-tested improvisation now approached the efficiency of purpose-built armor, demonstrating that practical ingenuity could rival formal engineering under extreme conditions. The farmer's involvement extended beyond the initial implementation. He collaborated with mechanics to refine the process, offering insight into material properties and structural reinforcement. His knowledge, derived from years of maintaining plows and machinery under harsh conditions, proved invaluable in optimizing weight distribution and impact resistance. The result was a reliable, scalable method that could be applied to multiple vehicles across diverse terrain without compromising mobility or speed. Soldiers also reported a profound sense of security. Knowing that trucks could absorb enemy fire instilled confidence in drivers and personnel responsible for cargo. Morale improved measurably, and the Army observed that units operating with reinforced vehicles displayed higher efficiency and cohesion. This human dimension, the confidence and reassurance derived from practical protection, was as critical as the physical armor itself. The initial success sparked interest at higher command levels. Officers began considering broader applications for civilian expertise and unconventional solutions in other logistical and tactical challenges. The plow blade armor served as a case study in adaptive problem-solving, demonstrating that individual initiative, even from outside the military hierarchy, could have strategic consequences. Ultimately, the first phase of the armor deployment achieved its primary goal. Supply lines were preserved. Trucks survived engagements that would have previously destroyed them, and soldiers gained renewed confidence. What began as a broken farm implement had transformed into a key component of battlefield resilience, illustrating the extraordinary impact of human ingenuity when combined with technical skill and operational necessity. As the plow blade armor became standard across multiple convoys, its effects rippled through operational planning, logistics, and morale. Trucks that had once been liabilities were now reliable workhorses, capable of carrying critical supplies across contested terrain. Commanders could allocate resources more efficiently, knowing that the probability of vehicle loss was significantly reduced. Fewer damaged vehicles meant fewer repair resources diverted from frontline operations, increasing overall operational efficiency. The armor also influenced the broader tactical environment. Enemy forces, observing fewer successful ambushes, began recalculating their strategies. Rifle and light artillery fire that once disabled convoys now produced minimal effect, reducing the effectiveness of German interdiction campaigns. While the enemy was unaware of the exact cause, the practical outcome was clear. Allied supply lines had gained an invisible advantage, bolstered by civilian ingenuity applied in the field. Mechanics continued to refine and expand the improvisation. Variations in blade placement, additional reinforcement in vulnerable areas, and improved mounting techniques enhanced durability and effectiveness. Trucks traveling through rocky terrain, river crossings, and open fields all benefited from these adjustments. Field reports indicated fewer vehicle breakdowns, a lower rate of lost cargo, and an overall increase in mission success. The farmer's original concept had evolved into a repeatable, standardized modification that could be applied rapidly in multiple locations. The human dimension remained equally significant. Drivers' confidence grew, morale across convoys surged, and mechanics developed a sense of pride in their collaborative achievement. The farmer, once a peripheral figure, became a symbol of practical ingenuity. Soldiers and officers shared stories of near misses averted by the armor, embedding the innovation in the collective memory of supply units. The success demonstrated that effective problem-solving could come from unexpected sources, inspiring other personnel to consider unconventional approaches to challenges. Beyond immediate operational effects, the plow blade armor had long-term implications for military engineering and planning. Field engineers documented the innovation for future campaigns, studying material properties, attachment methods, and optimal angles for deflection. The experience emphasized the value of adaptability, human creativity, and collaboration between civilians and military personnel. The incident became a reference point for subsequent logistical solutions, showing that small-scale ingenuity could scale into strategic advantage. In the weeks following deployment, supply lines stabilized. Convoys faced fewer disruptions, and critical materials reached frontline units consistently. Casualties from ambushes decreased, and the overall operational tempo improved. The improvisation had not only preserved trucks, but also strengthened the resilience of personnel, command structures, and logistical networks. The farmer's broken plow blade had achieved far more than simple protection. It had become an instrument of sustained operational success. Ultimately, the success of the plow blade armor reinforced a key principle of wartime innovation. The combination of practical skill, creativity, and resourcefulness can produce solutions as impactful as formal engineering. By transforming a discarded implement into life-saving armor, the farmer had altered the dynamics of supply convoys, improved morale, and contributed tangibly to the Allied war effort. His ingenuity, once overlooked, now stood as a testament to the extraordinary influence of ordinary individuals when necessity demands. Innovation. The story of the plow blade armor exemplifies the profound impact that ingenuity and human creativity can have in wartime. What began as a broken farm implement, mundane and overlooked, evolved into a critical innovation that saved lives, preserved essential supplies, and reshaped operational logistics. In a conflict defined by strategy, firepower, and sheer numbers, it was a civilian's practical knowledge that proved decisive on the ground. This narrative underscores the importance of adaptability. Soldiers, mechanics, and officers all faced conditions that conventional engineering and planning could not fully address. The farmer's solution demonstrated that real-world experience and creative problem-solving could complement formal military expertise, producing results that technology alone could not achieve. It was a reminder that in war, success often hinges not only on equipment or orders, but on the resourcefulness and ingenuity of individuals willing to confront challenges with unconventional solutions. Equally significant was the psychological effect. Confidence and morale, often overlooked in assessments of operational effectiveness, were profoundly influenced by this simple innovation. Soldiers trusted their vehicles to withstand fire, mechanics felt pride in their work, and commanders observed the tangible benefits of empowering individuals to innovate. The plow blade armor became more than protection. It symbolized resilience, collaboration, and the power of human creativity under pressure. Historically, this episode illustrates a broader truth. Extraordinary outcomes often emerge from ordinary circumstances. The farmer, armed only with experience, observation, and a broken plow blade, altered the course of supply operations on a scale few could have anticipated. His contribution, though modest in material, was monumental in effect. Ultimately, the legacy of the plow blade armor is both practical and philosophical. It reminds us that innovation does not always require advanced technology or complex systems. Sometimes, the simplest tools, applied intelligently, can produce extraordinary results. In the crucible of war, necessity and creativity converge, revealing the enduring power of human ingenuity. One broken plow blade became the silent guardian of Allied trucks, a testament to how ordinary individuals, through vision and determination, can leave an indelible mark on history.